Good afternoon. I'm Dr. P. Usharani, Professor EEE Department, RMD Engineering College. I'm going to brief about the topic of statistical analysis of random errors. Before that, the basics of error. What is error here is the difference between measured value and true value. There are three types of errors we have already noted. One is gross error. Due to human it is happening, okay, gross error. Second one is systematic error. Systematic error, you have three types: due to instrumental, due to environmental, and due to observational. These three are the factors for systematic error. Third one is random error. Even after eliminating all systematic errors, okay, the experimental results shows some variation from one reading to another. That is named as random error. It is an unpredictable error that may or may not occur. How can we reduce random errors? One of the methods is by statistical analysis of data obtained from multiple readings. Okay, here we are going to see one example sum. Okay, the question given us in a test, temperature is measured 100 times with variations in apparatus and procedures. After applying the corrections, the results are, they have given the one tabulation, temperature values in degrees Celsius, 397, 398, 399, 400, 401, 402, 403, 404, 405, and the frequency of occurrence, how many times it occurs. For each temperature, they have mentioned the values 1, 3, 12, 23, 37, 16, 4, 2, 2. They are asking calculate first one arithmetic mean, second one mean deviation, third one standard deviation, fourth one the probable error of one reading, next one the standard deviation and the probable error of the mean. The last question is the standard deviation of the standard deviation. Here the basic thing for arithmetic mean, how to calculate arithmetic mean, as that is what's the meaning for this, how can you calculate this as most probable value of the measured value. Variable is the arithmetic mean of the readings. Okay, that is the meaning of arithmetic mean. Second one, mean deviation. Mean or average deviation, we can say, which is sum of absolute values of deviations divided by number of readings. Okay, that is the definition for mean or average deviation. Next one is standard deviation, or you can say root mean square deviation. This one, okay. The formula for that is square root of sum of individual deviations squared divided by number of readings. We are considering the normal distribution curve or Gaussian probability curve and deriving the probable errors. Okay, that is probable error as a convenient measure of, which is convenient measure for precision. Okay, so from using normal distribution curve or Gaussian probability curve, we are going to find out the probable errors. Okay, in the probable error is the exact meaning here we can say, which is convenient measure of precision. Okay, so these are the data given. That is, I have prepared a table for the given data. I have wrote in column 1, column 2, that is temperature as the given data and frequency of occurrence. I have taken F. I have written in the table first column and second column the total frequency of occurrence. If I add that, the sum is 100. Okay, sum is 100. I am multiplying the temperature with respect to frequency of occurrence. Each values I have calculated and wrote here the sum of TF as 40,078. Similarly, I have calculated the fourth column as deviation. Okay, deviation. So here the deviation for each one. Okay, I have calculated for the given data. I wrote here minus 3.782 plus 4.22, and then I have multiplied this F, that is frequency of occurrence, into deviation. Okay, each set I have calculated. It starts from minus 3.782 plus 8.44, and d square I have calculated the deviation as here, and I have multiplied that d square of the d values, which is 14.288 to 17.808, and I have calculated f into d square, that starts from 14.288 to 35.618. The sum of fd square as 191.08, sum of fd as 102.8, because we need all the values for calculation of arithmetic mean, all the given questions. Okay, so find out first one, arithmetic mean. The formula here is sum of temperature into frequency of occurrence divided by number of divisions. That is here the sum of T into F. Here as we have, from the table we have seen 40,078 divided by 100, which is equal to 400.78 degrees Celsius. That is arithmetic mean value. Mean deviation D here as the formula is sum of F into D divided by sum of F. So from the tabulation, we found that the values as 102.8 divided by number of readings 100. So which the answer as 1.208 degrees Celsius. Third question, standard deviation sigma, which is equal to square root of sum of fd square divided by sum of f. So if I substitute the values, which is a square root of 191.08 divided by 100, that answer is 1.38 degrees Celsius. Next question, probable error of one reading, which is R1. I already mentioned that these are calculated using normal or Gaussian probability curve. R1 equal to 0.6745 sigma. I have substituted the value of sigma 1.38. After calculation, my answer is 0.93 degrees Celsius. Next question, probable error of the mean, which is Rm. The formula shows R1 divided by square root of sum of f. So I have substituted the values, which is 0.93 divided by root of 100. My answer is 0.093 degrees Celsius. Next question, standard deviation of the mean, sigma m, which is equal to sigma divided by square root of sum of f. So I have substituted the values 1.38 divided by square root of 100. So that answer is 0.138 degrees Celsius. Last question, standard deviation of the standard deviation sigma of sigma, which is equal to the equation shows sigma m divided by square root of 2. What is sigma m as standard deviation of the mean, which is equal to 0.138 divided by root 2. If I substitute that, my answer is 0.0796 degrees Celsius. Using the formulas, we have calculated all the values. Okay. Thank you.